Hey everyone, we're going to find the interval of convergence of the power series. So we're going to use the ratio test whereby the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n equals some limit, and we're going to force it to be less than 1. Alright, so substituting everything in, we're going to get the limit as n approaches infinity. Now looking at this, we're going to do our numerator part first. So this is going to be n plus 2 times 2x plus 1 to the power of n plus 1 divided by 2 to the power of n plus 1 times n plus 1 squared. This is absolute value. Or you could just put the absolute value on this x part. We'll just leave it like this. Now, we're going to divide by a sub n, which is the same as multiplying by the reciprocal. So that's 2 to the power of n squared, divided by, and just copy down, n plus 1 times 2x plus 1 to the power of n. All right. Now, let's simplify this so we can actually get the limit for our n. So I'm going to group these two together, and that's going to be n plus 2 divided by n plus 1. All right, and let's group the x's parts together. This is going to be 2x plus 1 to the power of n times 2x plus 1 divided by this one, 2x plus 1 to the power of n. Now let's group the two n's together. So that's going to be 2 to the power of n divided by 2 to the power of n times 2. And then our n squares. So we're going to have n squared divided by n plus 1 squared. All right. Now, as we apply the limit, we're going to, let's cancel some stuff out. We get this canceled out. This cancels out. Now, if you take the limit of this, so we're taking the limit as n approaches infinity, it's going to be absolute value of 1. Then we still have our 2x plus 1 divided by 2. This is also going to be 1. This is just n divided by n plus 1 squared. So you'll get 1 squared, which is 1. So basically, our limit is absolute value of 2x plus 1 divided by 2. Now we're going to force this to be less than 1. If you cross multiply, you're going to get absolute value of 2x plus 1 is less than 2. All right, now let's find our interval, and then we're going to test our endpoints. So if we have absolute value of 2x plus 1 is less than 2, by definition that means 2x plus 1 is less than 2 but greater than negative 2. So subtract 1 from each piece, and we're going to get negative 3 is less than 2x is less than 1. And then divide each term by 2. We're going to get negative 3 halves is less than x is less than 1 half. So basically, this is your interval right here. We have to test the endpoints to see if they equal negative 3 over 2 and 1 half, or they don't actually equal it. So we're going to test first for x equals negative 3 divided by 2. And we're going to use the alternating series test. So if we do that, we're going to get the sum of n equals 1 to infinity. And I'm looking at this right here, so I don't have to keep writing it. This is going to equal negative 1 to the power of n times n plus 1 divided by n squared. Now, looking at the alternating series test, it's going to be convergent because this is positive And then if we let b sub n equal n+1 divided by n squared, this is the same as 1 plus 1 divided by n plus 1 divided by n squared. Now, this is decreasing because this is going to be, let's see, b sub n plus 1 equals 1 divided by n plus 1 divided by n plus 1 squared, which is less than this. So it is decreasing, and our limit is 0. So the limit as n approaches infinity of our b sub n equals 0. So it satisfies this, so this is convergent at x equal, what was it, -3/2. All right here. Sorry about that. All right, now let's test 1/2, the other endpoint. So for that, we're going to take the sum as n approaches 1 to infinity, and what we're going to get is x plus 1 divided by n squared, and then the numerator is going to have 2 to the power of n divided by 2 to the power of n. Now this cancels out. All right, so therefore, this is n, sorry. All right, what's going to happen is we're going to get the sum from n equals 1 to infinity of n divided by n squared plus 1 divided by n squared. Now, this is going to equal the sum from n equals 1 to infinity of 1 divided by n plus the sum of n equals 1 to infinity of 1 divided by n squared. All right, this is divergent harmonic series. So this is divergent. This one converges with the p series. But if you have a divergent and a convergent, the whole thing has to equal divergent. Therefore, your interval of convergence is -3/2, 1/2, because the 1/2 isn't convergent, but at x equals -3/2, it is convergent. So that's your interval. Thank you. Have a nice day. Bye-bye.